you better. But he's part of Holland Greentech International, and he's the irrigation lead. Yes. So we are glad to have you, Mr. Bram, and we expect to learn a lot from you today. So at this juncture, I would like to hand over to you so that you can go for it. Thank you.
Okay, thank you very much, Elvis, and thank you for asking me to host or to lead this nice webinar session as part of your training sessions about climate smart farming and irrigation. The team in Ghana asked me to prepare a webinar about irrigation scheduling and water efficiency, which I did. I hope you can see my screen with the presentation. So I prepared a presentation for this webinar, and I always love to receive any questions or comments during the meetings or the online presentations that I do. So in case you have a question or any concern, then please use the chat to ask your to give your inputs. I'm also fine if you unmute and ask your question or deliver your input like that. That's not a problem. When you don't have anything to contribute, just kindly stay unmute so the sound will be clear to everyone, and I will be audible. So don't hesitate to leave your comments in the chat or unmute yourself at any point. So I can first quickly introduce myself. So my name is Bram de Vries. I am Dutch. I work for Holland Greentech for about 8 years now. I studied in the Netherlands at Wageningen University, which is a leading university in the field of climate, environment, and agriculture. What I studied there was international land and water management with a specialization of irrigation. And then with Holland Greentech, we do a lot with irrigation in the 12 countries where we are active in. I'm based in Zambia, so together with my colleague Patricia, we started Holland Greentech Zambia, whereby we focus also a lot on irrigation. So we selected the whole range of irrigation solutions that are still on the shelves when you walk into a Holland Greentech office. So that also counts for our office in Ghana. So I'm an expert in drip irrigation and micro sprinkler irrigation. I support the teams when it comes to designing product selection, training, etc. So I'm head of irrigation within Holland Greentech. As you might know, we are a close partner with Refillers Irrigation, one of the biggest irrigation companies in the world that takes micro irrigation, so that is drip irrigation and micro sprinkler irrigation, very seriously. Very modern solutions. Also when it comes to fertigation, so adding fertilizer to your system, smart irrigation, optimization of your system, but they also have the whole range of the drip irrigation hardware. So that's a bit about me. I also had the pleasure of visiting Ghana quite a number of times. The most recent one was about a cocoa irrigation assignment to do an assessment, and we gave advice as Holland Greentech about how irrigation can play a meaningful role in improving the production of cocoa in Ghana, and also to make the sector more climate resilient. So that was an interesting one as well. Just 1 second so I can see the chats in case there's anything. I've got a lot of notifications here. Perfect. So let's go into some content. So as Holland Greentech, irrigation is just one of the products that we have. We also provide greenhouses, hybrid vegetable seeds, soil testing, sensors that you can also use for improving your irrigation scheduling and efficiency. IPM, biological pest control, and we do a lot of workshops and training. This is one of the examples. So just to take you one step back about the definition for irrigation before we continue with efficiency. What if we want to talk about efficiency, we first need to have a common understanding about what is our definition of irrigation. So our definition, our mainstream definition of irrigation is the artificial process of delivering the right amount of water at the right time in the root zone of the plant. The plant wants to have the water in the root zone, and it's the job on the irrigation system and the operator to get it there. Okay, so it's an artificial process. So that means that, for example, rain is not irrigation, obviously, and there needs to be some human intervention, and then we can call it irrigation. So the right amount at the right time, that's where efficiency and scheduling is coming in. So if we look at how does the soil reservoir work, we see that they have roots which are in the soil reservoir. So the soil reservoir, the size of the soil reservoir, the volume of the reservoir depends on the crop stage, and basically the rooting area. So the deeper the roots, the bigger the reservoir of the soil where the plant can consume its water from, and that's where the plant gets the water. So this is a very important picture diagram because it also shows how water can be lost. Water can be lost when we look at the field level, at the field application efficiency by deep percolation. So the water infiltrates deeper than the roots can reach it. That is, we call it a loss because that water is not available for the plant anymore. And maybe it becomes available somewhere downstream in the system for other plants. But as a farmer, that is less of your interest. You want that water at the right time, at the right quantity in the root zone of the plant. So that is the goal. Then water can also be lost by the evaporation. So when you wet the soil area, the soil, when the sun starts to shine, the more area is wet on the soil, the water will be lost because of evaporation. Then with some forms of irrigation, you can also still lose water with runoff, like furrow irrigation, basin irrigation. Then water can also just flow from your field, from the surface out of your field. So it will not be accessible for the crop anymore. So that is another way to lose water that you try to add to the root zone of your crop. No irrigation system is 100% efficient. You will always lose some water somewhere, but we dive into that in more detail later. Also, if I go too fast or you want me to repeat something, then please let me know. So irrigation, why does the plant need the water? The plant needs the water for transpiration. Transpiration, just like people, plants also need to sweat to control the temperature of the plant. Photosynthesis, of course, the growth. So in the plant itself holds water. So the bigger the plant grows, the more water it also will hold. So it's a structural support. The turgor, like the cells need water for the structural support. That's why you see, like, if plant is drought stress, you see it starting to starting to bend, the stems start to bend, the leaves start to bend, so they don't have enough structural support anymore. An important one also that should not be underestimated is the transport of nutrients and gases in the plant. So the plant needs water to take up the nutrients, usually from the soil, to be able to take up your nitrogen or your phosphorus. Flow of water from the roots into the plant, into the leaves, into the fruits, the flowers, etc. is needed. So a shortage of irrigation can also lead to a deficiency in nutrients. So the transpiration is the biggest contributor to the water consumption. This really controls the flow of the water through the plant, and is the biggest one. So a healthy plant needs to be able to transpire enough water. Sometimes the presentation doesn't go or continue with the screen, so I hope you're now on the slide of too much water. Otherwise, I have to start sharing my screen again. So too much water. It's also possible to irrigate too much. We see it a lot with farmers we visit. Also with drip irrigation, where farmers irrigate too much. So what is a problem if you irrigate too much? One, it's of course water loss. If you have a farm and you have limited amounts of water, and you irrigate too much, it's a loss of your water. But it's also an energy loss. And you use maybe electricity or fuel to pump water onto your field. So every cubic meter of water that you lose is also in line with a certain amount of money that you lose, of energy that you needed to get that water there. This can be quite significant. Too much water, you have leaching of nutrients, especially nitrogen leaches quickly. So this is also a loss of money. You don't want your expensive fertilizer, or at least your nutrients that are already in the soil, to leach out. You have more risk of diseases, especially in the soil. So that's fungal and bacterial diseases. There will be less space for oxygen in the soil. Oxygen is also very important. The right balance between water and oxygen in your soil. So this can create bad conditions for root development and its functioning. It's bad for soil life, like good soil life, like earthworms, also need oxygen, and you don't want to drown them in too much water. So it causes imbalanced plant growth. Now, if there's not enough water, the plant will be stunted. You have small leaves, you have a weak stem, the root system will not develop well. So a weak plant is also more prone to pests and diseases. Just like as human beings, when we are strong and healthy, it will also be harder for a virus to make us sick. Also, the water productivity, so less yield compared to the ratio of water applied, would take place. So overall, a weaker plant, lower yield, and you would not really do any commercial farming. So if you want to irrigate efficiency, which is one of the topics of this webinar, we need to know how much water does the crop need. There are different ways how this can be calculated. I'm not going into too much detail of this. We don't have time for that, unfortunately. But one method which is defined by the FAO is one of the leading methods that uses a reference evapotranspiration. So it uses a reference evapotranspiration of like a grass that scientists tried on different places on the world, depending on the radiation, temperature, wind speed, and humidity. And then when you know the reference EV, so sometimes with like a satellite, for example, you could get that, or with a weather station, you can get that. You can make this crop specific by multiplying this with a crop specific factor, which we call the KC factor. So that's a crop specific factor. And so the ET0 is not dependent on the crop, that is just dependent on the environment. Then if you multiply that by the KC factor, we get the evapotranspiration. So if you look at information in irrigation and you find something like ET, it stands for evapotranspiration. So if it says ETC, the C stands for the crop. So that's crop specific. That's crop specific evapotranspiration. Here we see that formula, the KC factor times ET0. The reference crop makes the ETC, which is the crop specific one. Then we know how much water the crop needs. There are also other ways to determine your irrigation scheduling. Come back to that later. So if you are interested in this, you could download this FAO drainage paper number 56, and the whole method is described in there. CropWatt is a free, quite easy to use software that you could also use to calculate the crop water requirements. So you could also look for CropWatt 8.0, and it's a free. It's a bit of an old-fashioned program, but it works quite well. I'm not going into detail here. So we can just look at a few practical examples. For example, tomato. How much water does a tomato plant need? You would look at the different stages, like it's a seedling stage, the plant is in a development stage, or in a full-grown crop, or it's in a late stage. That's basically when the harvesting is already, that's basically when you're harvesting, or when the crop is like really almost coming to its end. So you see, of course, that when it's a seedling, it needs much less water than when it's a full-grown crop, up to 2, 3, 4 times more water is needed when the plant is fruiting, and when the plant is producing. That's when the plant needs most water, and it depends, of course, on the weather, the climate. A good one also to realize is that, like with irrigation, we often talk about millimeters of water. So 1 millimeter of water is the same as 1 liter per square meter. I don't have time to go into the details of that, but trust me on that one, that 1 millimeter is the same as 1 liter per square meter. So if we know the crop water requirements, we now come into the efficiency. So we have to look at what is the efficiency of your system. So if you use, for example, flood or furrow irrigation, it's of course much less efficient. So efficiencies in practice are between 30 and 60%, which is really quite low. Imagine you're pumping water and only 30% or 40% of the water ends up in the root zone. That is the definition that we're using here for the efficiency. So from your water source to what ratio of the water that you, for example, pump ends up in that root zone. So it can only be 30 or 40%. 50% is already quite a well-performing furrow irrigation system. Okay, most of it will be lost by runoff and by deep infiltration. Then we have sprinkler irrigation. Depending on the setup, you can reach efficiencies of around 70%. A bit more or a bit less is also, of course, possible. And then we come to drip irrigation, which is the most efficient system when it comes to water and also energy, where you can usually reach an efficiency between 85 and 95% if the system is operated well. So now I want to show you a video about the technical functionality of a drip line. A drip line is much more than just a hole where water flows out. So I hope that the sound will also come with you. Maybe Elvis, you can confirm if I press play, if you also hear the sound. If not, I will explain it myself.
Hello, Mr. Brown.
So can you hear the video?
No, there is no sound.
Okay, but you can see the video?
Yeah, we can see the video.
Okay, then I will just explain the video myself. So here you have the inside of the drip line. So you see water, but you also see very tiny particles that still manage to go through the filter that you have in the beginning of the system. And now you see here these black dots. That's basically a secondary filter, which is in each emitter, the water first needs to go through this secondary filter. So you see most particles will not fit through this filter, and it will just go, it will flow further and further. You see it's in the T-tip we have, it's a very big filter area. So even if 90% filter is clogged, still enough water will reach the labyrinth. So here we have the labyrinth. So you see that the water gets very turbulent, like it's flowing like more like a rapid in a river, and that makes sure that also the particles in the water cannot clog that. It will just keep going, and also it will reduce the pressure, so the water will just slowly trickle out, and it will not flow out too quickly, and make sure that out of each emitter the same flow will come out. So now you see that the outlet, which is a slit here, that's where the water gradually trickles out from. So also the slit has a bigger area, so that makes it more clog resistant. So that is like the technology that's in every drip line should have a small filter, a labyrinth, and the outlet. So those three items are included in a drip line. And with the T-tape, you really have a drip line which is designed to be like the most clog resistant drip line on the current market. So why would you want to go for drip irrigation? It's optimal constant water distribution. It has the highest water efficiency. Small water applications are possible, so you can have a short irrigation interval. Every day you can irrigate, or twice a day you can irrigate. The crop itself stays dry. That's a key advantage, especially also in a country like Ghana, where there's a high humidity. You don't want to wet like the leaves and the flowers and the fruits every time with water that you would have with like an overhead sprinkler. So it reduces the pest and disease pressure a lot. It's very suitable also for fertigation. I'll show you another video about what fertigation is, how you can do it. It requires relatively a low pressure, so also you need less energy from your pump. It has the most regular soil moisture content, so you have a more uniform growth, and also better mineral availability. It's perfect for row applications, and it's very easily adaptable to any field size. You can start very small, and you can also expand to a very big field size. So here's some examples of a drip system. This is a very simple, let's say, back garden system where you just have a drum on a small stand with different crops. This is the African eggplant here on the left, a big field irrigated by drip lines. Here we have another nice looking crop with our T-tape. You can also use it for carrots, as you can see here. So you can have 2 rows of carrots with just one drip line in the middle. Onions is also possible. Here we have a cabbage field. It's also possible to plant 2 rows of cabbage on each side. So you see very uniform growth. All the cabbages are the same size. You can have individual valves, so small valves that you can open and close for each lateral if you want. Also very suitable for solar system, as you can see here on the small demo we have in Tanzania. A picture of like how you can different zones. So in the middle you have the main pipe, and then you see that it goes to the different valves of different zones. So like with Holland Greentech, we can make a design for you to be sure that the right pressure and the right water is going to reach your plant. So you can dig this in, you can dig the polypipes into the soil. You could also leave them at the surface. Disadvantage, if you leave them at the surface, the sun will slowly deteriorate the materials, and also the water in the pipe can become quite hot. Yeah, but it also requires a bit more labor to bury it into the soil. So that's a choice for you. So I'm going to assume that also for this video, it's not possible for you to hear. So I'm just going to explain. I'll just forward a little bit. So here you see our drip line. So it's the black one, the transparent one also is holding is the one that looks like the one on the video we just saw. So here you see just next to the white line, you see the slits outlet. So the slit outlet also makes it possible to bury the drip line into the ground. So talking about water efficiency, if you bury the drip line under the ground, less water will also be able to evaporate from the soil surface. So one way to improve your efficiency is also to bury compared to the round hole where the water comes out. So you can imagine that the round hole is very small. If there's any material clogging that small hole, no water will come out, and your crop will have a problem with water. But with ours, with the slit, it's a much bigger surface, so the chance that that happens is much smaller. That's the labyrinth that you also saw on the previous video. All right. So this is a video where you can see that we just started irrigating. That's a pressure meter. So we just started for like 5 minutes. And you see already a very good distribution at each emitter, the same circumference of water. Here, of course, we see a sheep in the field, which is not advisable. They can also damage your drip lines, and of course, as soon as plant will not have a very long lifetime. So we advise this farmer to properly close his fence, because this here you see it's already almost walking over the drip lines. That is not the right way of doing it. So here we have a picture of a reservoir. A reservoir can be a good solution if you have a little bit of a bigger farm. You should usually store water in like a reservoir that is enough to irrigate for between 2 and 5 days on your field. So for example, if you have 2 hectares and you have a normal vegetable crop, that means you need about 100,000 liters of water on a daily basis. So you know, quite a sizable reservoir. So this will help with that or you have from river. You can slowly pump from the into the reservoir, so the flow rate of your borehole can be a little bit on the lower side. For example, 1 liter per second. For almost maybe 20 hours per day, you pump it into the system, but you don't want to use your drip system 20 hours per day. So then once the water is in your reservoir, from there you can use another pump with a higher flow rate to, for example, in 1 hour or 2 hours, irrigate your 1 to 2 hectare fields, or maybe 4 hours in total. So then you balance. From one pump you have a slow discharge, the other pump you have a low discharge. Always put a good fence around your reservoir. Kids love to play close to these reservoirs, and it can be very steep. And then if you can't swim, it's very hard to get out of it. So for safety, always put a fence around it. An example of a very big irrigation system. Does anyone here know what we are looking at?
Hello, Bram.
No?
Please
Yeah.
come again with
Yes,
a question. Come again with a question.
Can we see on this picture?
Yes, we can see.
Filters. I see someone replying in the chat. Indeed. These are big filters, big screen filters, automated system for about 300 hectare farm. How about this one? It's a bit harder to see. So this is part of a fertigation system. So here we see the tanks where the fertilizer are mixed in. We see second filters there. And on the left, we see the fertigation unit, nutrients into systems. This is needed also for big systems like 200 to 500 hectares. This is very effective. This is an example of a smaller system. Here we have a tank on a stand and a nice square field where a crop is about to be grown. Also a very nice setup, a shade house with a separate tank on a stand. So usually gravity fed systems, this we call a gravity fed system because it uses gravity from the water pressure in the tank to feed the drip system. We don't advise to use this for areas bigger than 1 hectare because then your uniformity will be too low. But for like smaller systems like this, it can be very effective. And we have a lot of good examples also in Ghana. So why do you want to invest in a good irrigation system? It has the potential to create optimal agronomic performances, and you need that for your bumper harvest, for more profit, save on your inputs and money, and don't take a risk. Like as a farmer, there are already many risks involved. Don't take a risk of having shortcuts in your irrigation system. It's your safety system, especially with the changing climate. You can't count on rainfall anymore, and you just can't afford the risk of losing your crop because suddenly you have maybe a 2-week dry spell. So irrigation is really your guarantee. So see it as like if you jump from a plane, you want to have a good parachute. If you're a farmer, you want to have a good irrigation system. Okay. I see a question. Hello, you mentioned the drip system can be buried underground. My question is that does this apply to all drips because the suction, as we are told, can draw in the sand and clog the system? Thank you very much for that question. The T-tape is specifically developed for this. So because it has that slit outlet, when you stop irrigating, the slit closes, and that makes it possible to also irrigate, to also use it subsurface. So you can't use this for all the drip systems. Thank you. Then we come to the irrigation efficiency and designing. We have a very knowledgeable team with Holland Greentech that can help you with this. So why is this important? Well, I already gave you the comparison with you. If you want to jump out of a plane, you better use the right parachute. So how much water is needed? That's number one for your designing, because the goal of your design is to get the right amount of water at the right time in your root zone of your plant. Secondly, we have to look at how much water is available. If there's a lot of water available, there's no issue. But if you have limitations because maybe of your borehole or your stream or your dam or whatever your water source is, it's very important to match the water need with how much water there is available. This sounds very common sense, but unfortunately, we see it in a lot of cases whereby maybe a farmer wants to grow he says, can you give me a quotation for 2-hectare irrigation? And then we find out that the amount of water that's available is only enough for 1 hectare. So then it's better to focus on 1 hectare and do everything correctly there instead of investing into a system and then afterwards your crop is stressed. I see another question coming in. Where we have to plow the farm this season, burying the drip line won't get it damaged quickly and become cost. Indeed, if you need plow, this can be a challenge. So there are two options. Either you use a way whereby you do land preparation only quite superficial, then you would bury the drip line 30 centimeters deep and make sure that you don't damage the drip line there, but only prepare the land above that, like reshaping of the bed, or you just bury it, let's say, only 3 to 5 centimeters deep. So then, when your crop is done, if you are a little bit gentle, you can still unbury it. So then you just sort of pull from the drip line carefully, and then the drip line easily comes to the surface because it was not buried very deep. And then you store it, you plow your field, you prepare your field, and then you can put the same drip line back. Yeah, so we have to develop a plan that meets the requirements of the crop and matches the sustainable availability of water. And ask a question about fertigation, like what fertigation options do you have to also improve on your fertilizer regime. And about that, I just want to give you this example of a Venturi system. This can be a very cost efficient and very practical, easy solution to apply fertilizer into your field on an extremely uniform way. So you see the blue tank over there, that's an example. You could put that, you mix your fertilizer, and it needs to be a soluble special fertilizer. You mix it in the tank, and then with the Venturi system, you can add this fertilizer into your drip system and then pump it to your field. So my colleague Richard is going to show you how this works. Or he will show you, I will explain what he is doing. So you see the pipe that he's holding with his hand. Next to it is a valve. So that valve is the main pipe to your field. So usually when you don't use the Venturi system, you completely leave it open so the water can flow freely from your pump into your system. But now you want to use the Venturi system. Let's see when is getting the Venturi system. Okay. So you see that the smaller pipe on the background is a bypass on the main pipe. And the Venturi is installed on this bypass. So the water can flow through the main pipe as usual. But if you would close that valve in the middle, water will also start flowing more and more through that bypass. And that also means through the Venturi unit. So what he's holding now in his hand, that's the Venturi. So you see that it has, oh, now I started the movie again. You see that transparent pipe, that is basically a straw. So you put that straw into your fertigation tank, and then when you start using the system, it will automatically suck up the water and the fertilizer that you mixed in the water. So in order to do that, you need some pressure difference. So you need to use a pump, and then the same pump as you always use. So you close that valve a little bit, water starts flowing through the bypass, through the venturi, and then the pipe will start sucking up the water. So you don't. So for this type of venturi system, fertigation system, you don't need an additional pump or an expensive fertilizer tank or anything. Just for maybe $200, you can be done, and you have a very efficient system. And you can save on a lot of labor. And as you know, farm workers don't like to add fertilizer into the field. So sometimes they broadcast or they don't put it properly next to the plant. So then you lose a lot of money, or fertilizer not reaching the place where you want to have it. So the different components we can help you with of selecting is like the pump, a filtration system. We need a good filtration system for a drip system, so your emitters will not get clogged. We need to know the right size of the pipes, the submains, so those are the pipes going to the different fields. The manifolds, we call those the pipes where we connect the drip lines to, and then at the end we have the laterals or the drip lines. Another important point of discussion is the lateral spacing. So what is the space between one drip line and the next? So usually it's good to choose a focus crop to say like, okay, this crop is very important for me, for example, habanero pepper or carrot. And then you select what is the best lateral spacing for that. And then you compare that spacing with other crops that you want to use in crop rotation. And you see if you can make some adjustments. So you can accept that in some fields, at some seasons, maybe for onion, it's a bit less efficient. There's a bigger space of land where you don't grow anything compared with maybe habanero pepper, where you see like a whole canopy coming. So you take your crop rotation into account, please. And this is what we mean, like we would have a bed and you would put one or two drip lines on the bed, and then you have the next ridge again. So a little bit about pressure. The higher the tank, the better when it comes to pressure. So because 1 bar equals 0.1 bar. So if you have a tank of 5 meter high, you would have 0.5 bar. That is usually quite nice for example, 1 acre or 2 acres of irrigation. But the 1 meter is really not advisable because the pressure in your system will be low, and the uniformity and the efficiency of your system will also be low. When you select a pump, also please look at how much water is this pump able to pump up in a day. So determine how many hours per day can I pump. So maybe you only have 8 hours per day electricity, so you can only irrigate 8 hours per day. So calculate then how much water do you have. So for example, if you have a pump with a discharge of 0.5 liter per second, that means that you can pump 1,800 liter per hour. So if you would pump for 8 hours, if that would be the max you can pump on a day, you can pump 14,000 liters on a day. This is something I would really advise you to know. How much water can you pump up on a day? Because that will tell you what is the right size of my irrigation system that I can use. Because, for example, with the 0.5 liter per second and 8 hours, that will not be enough for 1 acre. It will be enough for roughly half an acre, but don't start going for 1 or 2 acres. You will just not have enough water, and your crop will not do well. So this is an example of a system, a standard system that we provide. So it's a 50 by 50 meter field. And then you can see that we have 2 different zones. You see on the left, you see you see in the middle, you see there are 2 valves. So it's best to irrigate when you close one valve and then you open the other one. So all the water and pressure is focused on one irrigation zone. This is always the best when you use gravity, when you use a tank on a stand. Always just irrigate one zone at the same time. If you use a pump and you know the flow of your pump is really good, it's possible to irrigate multiple zones at the same time. If you have a very powerful pump, it might even be a problem if you only open one zone because the pressure there might increase too much and the system will also not like it too much. So match the flow of your pump with the flow of your irrigation system. Okay, there's a question here. What is the difference between a zone and a shift? For me, a zone is like a field that you can irrigate independently. So, for example, with one valve, you open it, and then a certain field, a certain area is being irrigated, and that is an irrigation zone. A shift, I think maybe you mean an irrigation shift, like maybe from 12 to 1 p.m. You have an irrigation shift. Is that what you mean, Prince? Yes. Okay. So a shift could mean that in one irrigation shift, for example, from 12 to 1, you have a shift. In a big system, it could be possible that in one shift you irrigate zone 1, 2, and 3. That is then a shift. So then you know, okay, shift 1, I irrigate zone 1, 2, and 3. Then the next shift, maybe the next day or the next hour, you already irrigated zone 1, 2, and 3. So then the next shift you want to irrigate maybe zone 5 and 6. Maybe those zones are bigger, so they can be irrigated only two at shift 2, and there are 3 fields, smaller fields, that you irrigate in shift number 1. So then the sum of the flow of one shift needs to be the same as what the pump can deliver at the right pressure. So that is only applicable for systems with a lot of zones. Let's say more than 4 zones or 10 zones or 20 zones. Then you look at like what shifts do you have. So for a small field like this one, you could say you have 2 shifts. Shift 1 is zone 1 and shift 2 is zone 2. Then there would not be a difference in a small system. So here is an example of a 1 hectare setup. So here you see that the main pipe, here the bottom part is divided. This is a very cost-effective system that we provide, because then you just need a short piece of polypipe, and then at the end you have 4 zones. You see those valves that are indicated a little bit more on the top. Each valve operates one irrigation zone of 25 by 100 meters. Oh, this drawing is not in scale. So then you can first irrigate the field all the way on the left, and the one next to it, the next to it, the next to it. So why would you want to have different zones? One, your pipe sizes can be smaller. So the system, you save money on pipe sizes. You do need to buy a little bit more valves, but in like a hectare situation, you would save money. You can have more planting dates. It's easier to plant on different stages, like every week you plant, or every other week you plant the next field, so you have a more consistent supply. That's usually not very nice to grow, for example, 1 hectare of cabbage. All the cabbage is already at the same time. You have a nightmare in logistics. The price at that point might just be low, so it's better if you every 2 weeks you plant a quarter of a hectare. You would have a more secure business case. Here's some pictures of irrigation components, starter connectors. We have our T-tape. You see that puncher in also on the picture. That's also very important one for installing. When you look at efficiency, sometimes I call it like the operational, like the push method is used, whereby you put a fire and you have like an iron bar, and then you burn the holes in the pipe. You can imagine if you do that, and then you want to install the nice green connector there on top, you would get all kind of leakages, which really reduces your water efficiency. These are mainly the HDPE components, but we can also make the system with a PVC pipe. You can always make like a sketch of how your system looks, like. This is also a simplified system. A gravity system. Okay, so these T-tape systems control. So what are some take-home points to improve efficiency? Check and clean your filter. I didn't talk about that important thing yet. If your filter is clogged, it really reduces the pressure in your system and the flow in your system, and this makes your system less efficient. So not all the drippers will release the same amount of water anymore. If you never clean it, at some point even no water will come out. But weekly checks, or maybe even 2 times a week, like I would always say, clean your filter on Monday. It's a good start of the week, to make sure that you don't have unnecessary pressure loss and uniformity problems in your fields, which leads to that you cannot get your right amount of water at the right time to your field. So regular flush your system, so open the drip lines at the end on a regular basis. So ensure that the drip lines are nicely fit on the beds. Sometimes you see, because of wind or other reasons, maybe the sheep that you saw on the video, the drip line blows off the bed, and then it irrigates the walking path or a place where there are no plants. So keep them straight. Do that before you start irrigating, or bury with, like, at some places you can just put some soil on the drip line to keep it at the right place, or use some simple sticks to keep the drip line well at the place, especially in the seedling state. This is very important. Also ensure that the wiring you find on our T-tape should face upwards. That improves the lifetime of the system. And try to have the optimum pressure in your system. So the optimum pressure should be between 0.5 and 1 bar for best irrigation efficiency. So that means if you don't have a pressure meter, just try to squeeze into the drip line in between your index finger and your thumb. If this is very easy, the pressure is not good enough. If you really have to put some effort of squeezing, but it's still possible, if you put the effort to squeeze, the pressure is good. If it is like not possible to even squeeze in the drip line, then your pressure is too high. All right, then we come to the part of irrigation scheduling. So irrigation scheduling, what does that basically mean? When are you going to irrigate, for how long, and with how much water? That's irrigation scheduling. So you have to make your irrigation scheduling, and to do that you can use different tools. One of the tools, which is the cheapest tool and one that is available for 99% of us, is your hand. If you dig 20 centimeters into your soil in the root zone of your plant, and you get the soil, and you find the soil like you see here on the picture, a bit on the left, it's a bit sticky, the soil particles stick together. When you're squeezing it, you feel it's like a little bit cold. You feel there's a bit of water in the soil. It's a good indication that the humidity in your soil is quite good. If you're squeezing it and just all the water seeps out of it, like you are squeezing a wet sponge, then there's too much water in your soil, then it's too saturated. But if the water on the picture like next to it, it's just like sand, like it just falls apart in your hand. When you squeeze in it, it just becomes loose and it sort of falls on the ground. Then it's too dry. So this is the most basic way how you can look at it. You can also go for a more advanced device, for example, the Blue Lab Pulse meter you see there on the left. We also provide those on order, so you can stick those two rods in the soil at the depth you want it. The device connects with Bluetooth with your phone, and automatically it saves the water percentage, the humidity percentage of your soil on your smartphone. So this is perfect. So it also saves it, so you can always see later, like, oh, what was my soil moisture then? What was my soil moisture then? If you like data, you can export all this data also into Excel, do your analysis with it. It also gives you the EC value. So EC stands for electric conductivity. So that also tells you something about how much nutrients are in your soil. And the lower the EC, the less nutrients are available in your soil. So that's a very good device to have in hand. It's very mobile. You can just bring it with you and test the soil moisture at different places in your field. Okay, so a question coming in from Tony. Thank you. Is the squeeze method for is water passing through? Yes, exactly. So you will because the water still needs to fill up for the system to start working well, and that's when you squeeze. Thank you for that question. So if we look at the smart irrigation system, what is a smart irrigation system? For me, a smart irrigation system is when you have tools that can help you with water scheduling. You have an efficiency of your irrigation system and the pump, and you could also think of something like water level monitoring and having good insight availability. So in order to do that, you can make use of sensors. What can you measure? Think of soil moisture we talked about as the main one, but you can also think about UV, so the light. So like the high-tech farmers that use light sensors to determine how much water the crop needs, because they can calculate with the amount of light what will be the photosynthesis, what will be the evapotranspiration of my crop, and they determine their irrigation scheduling based on light. You can think of pH values of your soil, but also of your water. So there are a lot of things you can measure. If you don't measure anything yet, I would say start with the soil moisture, which is the most important in most cases. Then you see communication protocol. So if you use sensors, they need to communicate the data in a certain way to you. So you could use Wi-Fi, or you can use other kind of radio signals or other protocols. Since we are living in the 21st century, more and more goes with internet, Bluetooth, Wi-Fi. So I would advise to go look for solutions that those kind of options. Like a system we also introducing now is Holland Greentech. If you have a Wi-Fi system on your farm, you can open and close irrigation valves using your smartphone, using Wi-Fi or Bluetooth. Yeah, and then the physical level, so that is like the automated valves, controllers, yeah, fertigation systems. I think also fall under that category. So for me, if we look at smart irrigation, you can look at different topics. So one is monitoring and decision support. I think that is the lowest hanging fruit for most farmers to get more guidance in, okay, how's it going with my farm? What do I have to do? What data to base decisions on, instead of just gut feeling. So, okay, today I'm going to irrigate 1 hour because I have the feeling I have to irrigate for 1 hour. You can think of remote sensing, so that's like satellite based, or drone-based information. Another is like precision irrigation that really has like automated filter, for example, that you can install in your system. And the fourth one is the more emerging, very innovative water smart solutions like laser guided solutions that can help you to give information on irrigation. So these are very novelty technologies that as Holland Greentech, we keep a keen eye on, like what are the newest developments, and we can help companies test those technologies, and then we can assess like, is this actually practical for the farmer? Does it have added value for the farmer? And if so, we can start, for example, working together with those suppliers to stock those new solutions. But we can also say, well, maybe in a few years this will be a good solution, but you first have to do a little bit more research and development to make this a practical solution for farmers. Yeah, so you can look at soil monitoring, plant monitoring, and environmental monitoring. Environmental monitoring would be more like a weather station that could be nice on your farm to know like what's the exact weather. It's not always easy to find, and the accurate data of, for example, the humidity, temperature, and wind speed. So you want a smart irrigation system because it can really help you to just make that extra step of water efficiency. Your data-based irrigation scheduling is possible. You can save energy, you can reduce on labor costs, and you can include like remote controlled operations if you're not always on the farm, but you want to know for sure that your irrigation, your plants are getting water every day. It's a good idea. Yeah, please, if you have a comment or a question, please unmute or put it in the chat. I'll skip this slide for now. So how do you select the right technology for you? Think about what is like really necessary for you to know. If you don't have any knowledge at the moment, you don't have any data on how long to irrigate, how to do scheduling, then look at those decision and monitoring supporting tools. Don't immediately go to automated valves. If you already have quite a good idea what's happening in your field, you know how much water your plant needs, but you're annoyed that maybe a farm worker doesn't always opens and closes a valve at the right time. It happens a lot. Maybe somebody forgets for 1 hour to close a valve, and then you lose your money. I'm already saying money, but of course water and also money. So then invest in, like, for example, remote controlled valves that we can help you also with as Holland Greentech. I can share the slides with I see a question of Elkana, so I can share the slides with my colleague Elvis, and then I hope he can distribute them. Great. Well, so then we have another nice solution here of monitoring and decision support. This is a free app. You can download it in the Play Store if you look for a real view. It's currently for free, so it gives you an index on vegetation. So it shows you which areas of your field do you have the best vegetation compared to the other parts. So it's a relative comparison. And you can also look at field wetness. So maybe you have a leakage in your system or a drip line is blocked. You would be able to see using the app, hey, why is this part of my land much drier than the other part? And then it can assist you to go there and see like, okay, specifically what is happening there. Maybe you find a leaking pipe or you find a blocked pipe or something like that. I will not go into this. This is for farms bigger than 250 hectares. If you're interested in that, you can send me an email. That brings me to a very nice solution called Croptimal. Croptimal is the second version of something that Holland Greentech also designed together with a company called Future Water from the Netherlands. Together we designed an open source information tool for small scale farmers on specific irrigation scheduling. So it uses open source satellite data. So open source means that the data is openly accessible, and then we process this data with a very good algorithm to come to those crop water requirements. So I earlier mentioned about the evapotranspiration of the crop, the calculation, the Kc value times the ET0, all of that is done for you in this algorithm of this platform based on satellite information. So it gives you a crop-specific irrigation advice for your specific field. So we need your GPS coordinates of your field. We need the type of drip line that you have on your field, the total length of drip line you have, the bed spacing, and then on a daily basis we can give you an irrigation advice of how many minutes to irrigate. So I'm very excited about this technology. So I will give you a small tutorial on this. So I would also really like to invite you if you feel like, hey, this is something for me, this is something for my farm. We are currently offering, because we are doing this webinar and we are doing this irrigation course for you. If you're interested, for one season, we can offer this irrigation advice, this irrigation schedule for free to you. So if you provide us with the information, like you are in contact with my colleague Afia or Prince or Elvis, if you give them the information of your field, what they are requesting from you, we will put you in the system for free for one whole season. So that means you would get a daily WhatsApp message. Good morning, for example, good morning, Kumi. The advice to irrigate field A today is 43 minutes. And then you can follow the advice and see how well your crop performs based on this advice. So if you're enthusiastic about this, please contact, I think Elvis would be the good main contact person, and we're going to put you in the system. It is very new technology, so in case you would have more questions about it, or like Elvis, or we are very happy to help you with this. So as you can see, it needs irrigation specs, the crop type, so the planting date, type of your crop, and also the expected last harvest date. So we have a good time frame when you need the advice, and then the program will calculate how long to irrigate for you. It unfortunately cannot yet take rainfall into account, so this advice is very accurate when it's like not raining. But when it's raining on the day, you also need to purchase a rain gauge, measure the rain. So then, for example, if we know, if you get advice, irrigate 43 minutes, but it also rained 10 millimeter, what will happen is we give you a conversion table to say like, okay, because it rained 10 millimeters, reduce the irrigation time with, for example, 12 minutes. And then you had like advice of 42 minus 12, irrigate for 30 minutes, and you're safe. So I'm going to try to now share another screen. 1 second. Okay, I believe you can now see my new screen. So this is the Croptimal app. So what's nice about this is this this is the interface how, for example, Holland Greentech staff like Elvis or Avia can see the system. So we can go to like a farmer. So we select a farmer. So I can do the example farm here, for example, farmer Bram. I go select fields, like a farmer can have multiple fields with multiple crops. Well, in this case, I have one field. So I select the field. Then you can see the crop I have there is cabbage. So I see that my irrigation advice is 47 minutes today based on my irrigation system and the crop. So this is very easy. It will just tell you this is your irrigation advice based on the information that was available from the satellites. So you can just see last update. Okay, so it was updated this morning. You still see the information, you see a phone number. I want to receive this message on WhatsApp, so I don't have to log into this platform every day. It will also give me the weather forecast of the week, so it also tells me the temperature and the expected rainfall. And if I scroll further down, you also see the historic irrigation advice. So here you see, for example, on in March, 22 March, the advice was 40 minutes, or on February 21st, 38 minutes. On the second, let's see, the 4th of March, it was 50 minutes. So then it must have been quite a hot day, and the crop was in good performance. So this can also help you with some record keeping. So you can also change the level, I believe. So here you see it also per day, like, okay, this day it was 33, 33, 40, 58. So you can look back at the history. And here on the right, you see you can check if the coordinates that you gave of the fields, if they are accurate. Like in this case, it is the proper field. So you can just double check if you are talking about the right field. So this is very easy to use. So as a farmer, you have two options. Either you the WhatsApp message and we add you to the system. If you want to have access to also the weather forecast and the historic irrigation advice, like you want to log into the system yourself, it's also possible. We can make you, especially for farmers that maybe have multiple fields, maybe they have 5 fields or something, and want to have advice, you can log into the CropTool app as a farmer, and then as a farmer you can choose the different fields, and then for each field you can see just the same layout like how I'm demonstrating now. You can see the irrigation advice. So those are the two options. So you can let us know which option you like most. Let me just show you what information is needed when you go to the field. So if we say, for example, we add a new field, this is then what we can do as Holland Greentech. So maybe we go for Okuzua. So we need to know the latitude and the decimal degrees. So when you go to Google Maps and you select your field on Google Maps, you go to your farm, select the field, you find the latitude and the longitude. So the latitude is the first number, and then the longitude is like the second of the coordinates on Google Maps. So you can just copy them here. You add your soil type: sand, sandy loam, sandy clay, silty clay. You put the effective bed width. So the effective bed width is the bed width where you expect it when the crop is in a mature stage, the canopy will cover on. So for example, if you have a habanero pepper and you have like maybe 2 rows of habanero pepper on one bed, when the crop is big, the effective bed will be definitely 1 meter. Like the canopy will cover at least 1 meter, maybe even 1.2 meter. So that's the effective bed width you put. You put the emitter spacing of your drip line. So for the T-tape, it would be 20 centimeters. So you put 0.2. Number of drip lines per bed. I know in Ghana, you like to have 2 drip lines per bed. So usually it would be 2, but 1 can also work fine. Then you also put the total drip length of that field. So maybe you have to calculate that. If Holland Greentech just installed the system, we of course know the length because we sold you those rolls of drip line. So like if we installed 1 roll of drip line, okay, it's 2,300 meter of drip line. We fill in the initialization time, so that is the number of minutes it needs for the system to become under pressure. So usually that's 5 minutes. And we put the emitter flow rate, so that would be 1 liter per hour for our drip line usually. Maybe we do a bit less when it's a gravity-fed system. So then we can press create field. We have a new field. Then we can go to the crop. So we have the field information is not dependent on the crop. Then we go to the crop. So for example, field A. Then we can say add a new crop. What are we planting on this field? Well, we can say maybe sugar beet or broccoli or maize. Well, let's say potato. We say sowing date. Well, we planted maybe today. We expect to harvest. Well, let's say in June. Create crop. And then the crop is assigned to that field. And then the next day when we go to irrigation, you can select the farmer and the irrigation advice will be ready for you here. But now, because it was just initiated, there will always be only tomorrow the advice of the crop will be available that we are just initiated. But we already can see the weather forecast will not be raining much. So definitely some irrigation will be needed. I see a question from Ahmed, sorry. With unreliable weather data for those of us in North Ghana, how efficient can crop thermal be? It can be very efficient because it uses the satellite information to measure the evapotranspiration. So it is just as accurate for northern Ghana as it will be for I don't know, maybe Kumasi or the coast. The only limitation is the rain. Like the satellite information nowadays is unfortunately not precise enough to really know the rain on your field, because rain is so spatially different. Maybe it rains at your neighbor's place, but not at your place. So the satellite cannot measure that accurately enough yet. So for that, you would need the rain meter that I mentioned before. So then you can make the adjustments based on the rain. I hope that answers your question. All right, then I will continue with the presentation. So this is a nice tool, crop them all. So please contact Holland. I hope to see many of you that will use this special offer of us to give this advice for you for free. Going to share the presentation again. Yeah, so some other examples of technology you can use to improve your scheduling and efficiency. Sensorterra, it's a Dutch solution of soil moisture sensors. So you can see they have sensors that are stationary. So you plant them, you install them in your field, and then afterwards you don't move them usually from one place to the other. So it's a stationary sensor. So they have different depths like 15, 30, 60, and 90 centimeters. So depending on your crop, you can determine which ones are most important for you. I would always advise to have at least 2 different depths so you can see what's happening when you start irrigating on different depths. So the 15 centimeter and the 30 centimeter are best for vegetable farming. But if you have maybe a cocoa or you have another, maybe a fruit tree, the 60 and 90 centimeter can also be interesting. So at least like the 30 centimeters is a good one for the root zone, and 50 centimeters. So usually you would see if you have, for example, the 15 and the 30 centimeters that after you irrigate, first the soil moisture level on the 15 centimeters is going to drop. That one is consumed and also evaporation first, and then the 30 centimeter will follow. So sometimes it can be fine to leave the 15 centimeter a bit dry, as long as you can then see that on 30 centimeters it's still water and your crop is well established. You can irrigate them later. So they have a very nice app on your phone where you can have all the information always available. I added some information here. Here you see a graph how like the different colors show the different sensors, so you can sort of see that it's all the time in the right. It's not too wet, it's not too dry. So you can see that with this technology. So for this technology, you need a LoRaWAN network on your farm, which costs around $800-900. So that means this is a solution you usually use for, let's say, more than 2 hectares with multiple sensors. So then what you need one of those networks, and then you can add as many sensors as you want. So usually I would say put 2 per irrigation zone. So for each irrigation zone, you have 2 points where you always know the moisture level. Then another solution here is Quantified. So also a nice company that developed sensors for greenhouses and also for the open field. For this one, uses like a 4G SIM card to send data also to the internet, to the cloud, and then you can access the information on your phone. Yeah, they have weather stations as well, so you can add like the weather station information, soil moisture information, all of that into one app that you can then access. So it's a bit cheaper because you can use a local SIM card. You can use a Ghanaian SIM card. You put it in the system. You just need to buy some bundles now and then, and the system will work. So we can also provide this for you as Holland Greentech. Some examples of some sensors. So this is a sensor. See, it's also in soil media, very good. You can measure the EC as well. So link to the website, etc., can be found in the slide. So the Firefly, you see Firefly, that's the module where it's connected to. So it's called a Firefly. That's the node that will get the information from the different sensors, combines the data, and then it sends it to the cloud. That brings me to the end of this presentation. I still have enough time to have like a small discussion with you. Thank you for your attention during the presentation. I see that most of you stayed here from the beginning till the end in the webinar. So that's already very nice. I would like to ask Elvis if you could guide the discussion or the questions that the participants still have. I'm here to give you any information. I will try to answer your questions as good as I can. Back to you, Elvis.
Thank you very much, Bram. Thank you very much for the presentation. Elvis is not around, but I'm taking the place of Elvis. So far, so good. Anybody have any question on the presentation so far? Anybody with any question?
No, I don't have a question for now.
All right, okay. So anybody else? Anything you don't understand? You can Bram is here. Anything you didn't understand right from any right from our teachings. So this far, anything you don't understand, you can share. So Bram help us with it.
Yeah, so maybe there's a specific challenge on your farm when it comes to irrigation that you would like to share with the group so we can brainstorm about it.
So personally, I have a question. Bram, what do you, in terms of pipe sizing for irrigation projects, what informs pipe sizing for irrigation installation setup? What is going to inform your pipe sizing for your irrigation projects or irrigation setups?
Mm-hmm. Okay, that's a good question. Pipe size, diameter of the pipe size is very important for your irrigation design. So what you want at the end, what is the most important is that you want the right pressure in the lateral, in the drip line or in the sprinkler. So you start calculating from there, and you look at the distances that the water would have to travel at the different components of your system. So you have your main pipe, you have your sub-main, you have your manifold. So the length, usually you know that, like the length of like your manifold, you know it, the length of the sub-main, because all of that you can, it's not so difficult. So then what I usually do is I see like, okay, what's the flow that is needed for that irrigation zone that I want to irrigate at one time. So for example, if that flow is, let's say 20,000 liters per hour, so 20 cube per hour, I can try and play around with the pipe sizes. So I can, for example, start with a 40 millimeter pipe because of experience, and I'm like, okay, maybe that one can work. The smaller the pipe diameter, the more pressure loss you have in your system. So when you use like the hydraulic calculator that we use as designers, like Reflux has a hydraulic calculator, you fill in like the length, like maybe it's 100 meters or 50 meters. You fill in the diameter, 40 millimeters, and you fill in the flow. So then the tool will calculate the speed of the water in the pipe. So the smaller the pipe size, of course, the faster the water needs to flow. So the more kilometers per hour the water needs to flow through the pipe in order to give that amount of water to the field. So the faster the water flows, the more resistance you will have in the pipe. Just like when you drive a car, the faster you drive, you put your hand out of the window, you will feel more and more resistance the faster you go. So that's also what the water is feeling. So this hydraulic calculator will calculate, for example, okay, you will have 1 bar of pressure loss in your pipe. So there are two things. Either you say, okay, if there's 1 bar of pressure loss, and let's say there's 1 bar of pressure loss in all your pipes. You want 1 bar of pressure on your drip line, and then there's 1 bar of pressure loss in the pipe. So that would mean that your pump needs to deliver 2 bar of pressure to, one, compensate the pressure loss in your pipe, and still have 1 bar of pressure, let's say, left at the field. So then you know, like, okay, I need at least 2 bar pressure pump. But you also still have a filter. A filter usually also has 0.5 to 1 bar of pressure loss. There are some bends in the system, so it's better. Maybe you need to go to a 3 bar pump. Okay, if that's too much for you, if you feel with a 1 bar that's too much pressure loss, then you go one size bigger. So you go to like a 50 millimeter pipe, and you see that the difference is huge between, for example, 40 and 50 millimeter pipe when it comes to pressure loss is huge. So now maybe there's only 0.3 bar of pressure loss when you increase the pipe size. So that can also give you the conclusion, I don't want all these bars of pressure loss in my pipe system, because also the pump will have to work harder. I have to buy a more expensive pump, more electricity. So you choose for slightly bigger pipes, like 50 millimeter, 0.3 bars, not much pressure loss, and the system will work better. So you use, in short, you determine the flow and the pressure you need in field, and then you use the hydraulic calculator for the different parts of your system. How much pressure loss do I have in my main pipe if I have it 50 millimeter? How much pressure loss do I have in my sub main if I make it 14 millimeter? And then you make some adjustments, you play around with it, and then at the end you come with a system that you don't have too much pressure loss in your system. You can select the right pump, and the right pressure will be at your field.
Thank you very much, Bram. I think I really got all that you were saying. There are a few questions here that I personally want to answer. Somebody wants a quote for 2 hectare. We can give you a generic quote for 2 hectare. I don't know if you are in the group. You can share your details. We can give you the generic quote for 2 hectare projects. Okay. So I think I also have one question in addition. Bram, much concern about how you also size filtration units. In a case, what is going to influence because in the picture that you showed in your presentation, I saw you were saying something about was it 250? Was it 500 acre project? Or was it
Oh, that big one.
Yes, so
yes, I think that was.
Yeah, so ideally I was thinking, why not sand filters? Why those I don't know if it were those disc filters, they were arranging array. So my question is, what's inform the type of filter you are using, and then also secondly, what will inform the filtration units, the footprints of the filter, and then the size of the filter also when you are doing irrigation setup.
Yes, okay. So ideally, you first look at the water quality. So there's a big difference if you get water from a swamp or you get water from a borehole. Usually boreholes are quite clean already. There's not much organic matter in a borehole. Maybe there's a bit of sand, but usually that's more or less it. And you have like some calcium and stuff, but from a swamp, it's usually a challenge. Like you pump up all these like algae stuff, organic matter is very hard to filter out. Then you also take the scale of the system into account. Like a smaller scale farmer with like half a hectare, 1 hectare of land, that's just not feasible to advise. Okay, use a media filter of $3,000, and that's not going to work out. So that's also something to take into consideration. The T-tap is extremely clog resistant. So when you use, for example, water from the reservoir, from a swamp, step number one would be to get the cleanest water from that swamp into your system. So so for example, you can also do that by adding like a floater to your pump, to the inlet pipe of your pump. So the pipe, that the inlet of your pump is always like floating, let's say 30 centimeters under the water level. There the water is relatively clean. If you don't use the floater and the pipe will just land on the bottom, you can imagine it sucks a lot of dirt, like it's like a vacuum cleaner in your swamp. So then you get a lot of dirt in your system. Usually disc filters are a bit better with like organic materials than screen filters, in my opinion. So I would go for a disc filter. They're a bit more difficult to clean, but they are also a bit more they have a longer lifespan. Like that filter, the discs don't break so quickly. So then you would just have to clean it more often. That would be my advice. Put them two next to each other, for example, like parallel to each other. Clean them really regularly well. Then things can work just fine. Looking at the size, like you have to look at like the catalog, and you look again at the flow rate. The flow rate determines almost everything with the irrigation. So if you have a system that only needs, let's say 6 cube per hour, you can get away with a 1.5 inch filter. If a system needs 20 cube per hour, you look in the catalog and you see, okay, a 2 inch or 2.5 inch or 3 inch, whatever filter. You see the min, and you see like the max flow. Like you should not exceed the max flow. It's better to be like 30% under the max. So if a filter shows you in the catalog like max flow 15 cube per hour, and you calculated you need 10 cube per hour in your system, then you have a perfect match. Like you don't work on the maximum capacity of the filter. If you go too much, it will again mean more pressure loss in your system. I hope that answered your question.
Thanks, Bram. Thank you very much. I think Tony is also saying.
Hello.
Okay.
Please, I have a question. I have a farm which is located 400 meters from the source of water, and I'm using a pump to abstract the water from the sump to the field. I want to connect a venturi. Should it be at the foremost or at the closer to the farm? And also, should it come before the filter or after the filter? Thank you.
Thank you very much. That's two very good questions. For your first system, like for your first question, where do you want the venturi system? Usually it's placed quite like after your pump, relatively close after your pump. That is the most usual setup because there the pressure is still highest. But it can also work closer to your field if that is very convenient for you, and it's just like a did you say 400 meter pipe?
Yes.
Yeah. What's the diameter of the pipe?
2 inches.
2 inch. Okay. Yeah, that's quite a long pipe, and the diameter is okay, but it's not huge. So based on this, I would say place it close to the pump. Then your second question, after or before the filter, you always put a filter after the venturi. So in that bypass, you can add an additional filter, like just a small filter, like a 1 inch filter that specifically filters the water that you just are sucking up with the fertigation. It's always possible that the fertilizer is not completely mixed well, and then you want to filter it out with like an additional filter, that's a possibility, or you just use the filter you already have in your system. So then you place the Venturi before that existing filter.
Okay, there. Thank you very much.
You're welcome. I see Tony has a question. Please, can you shed some light on the term bar? I can't quite grasp it. Yes, I can. Bar is it's the water pressure, and the unit of that is bar. 1 bar is equals 10 meters of water height. So imagine you have a tank on a 10-meter high, and you connect a tube to that tank. You fill the tank with water, and you try to hold like the pipe. You close the pipe with your hand on the bottom side. Then a column of water of 10-meter high is going to push on your hand. So then the pressure you feel on your hand, so the power you need to keep the pipe closed, that equals 1 bar of water pressure. So then you know how 1 bar of water pressure will feel. So that is maybe gives you an idea. So when we're talking about pressure loss, maybe you have that, like Mr. Ahmed just mentioned, he has a 400-meter pipe. So then close to the pump, when you would measure the water pressure, you imagine you make a small hole in his pipe, and you place your hand there. You need maybe really a lot of power to keep that hole closed, because it's so close to the pump, and the pump is just pushing the water in there. But now 400 meters further, the water has traveled to the pipe, and it has lost pressure because of the friction with the pipe. Like the water is moving with a certain speed through the pipe, and it creates friction. So at the end of the pipe, when you do the same, you drill a small hole and you also put your hand. Maybe it's very easy for you to close it because the energy is lost in the process in the pipe. I see that Ahmed is also asking, do you have the mobile sensor? I don't think we have it in stock, the pulse meter, but it's possible to order it for you. You can contact Elvis or Prince.
Okay, I have a question.
Please go ahead.
Okay, this is Reginald. Yeah, and my question is, on my farm, I have a 5,000 liter water tank, and which is supplying water to my plants. And the height from the ground is 5 feet from the ground. So I want to know how many bars of the pressure that comes out of my tank to the plant at any given time when the tank is full.
Okay, good question. So you have a 5,000 liter tank, and the height of the tank is 5 foot. So I think 5 foot should be about 1.5 meters. So if your tank is full, then we can add 1 meter more of water pressure. Water level increasing the water pressure. But means that your tank full, you have 2.5 meter of water pressure, static water pressure. So if nothing is, if no water is flowing. So 2.5 meters of water pressure is the same as 0. So you just simply divide it by 10. So 2.5 divided by 10 is 0.25. So that is the max pressure you can say you have in your setup. Now you're starting to open the valve of your system, and the water starts to flow. So this will lower again because of so your field, I would expect that you cannot have more than 0.15 bar of pressure usually. So this is when the field is flat and the field is not too big, this can be fine, this can work well. But for example, if your field is an acre or something, you're going to have uniformity issues. So then you really have to put your tank on a higher stand. For example, 4 or 5 meter high stand would be much more effective when it comes to uniformity.
Very much.
Okay. I see that the other question is answered in the group. Maybe we can handle one more question.
Yeah.
Hello.
Thank you so much for the presentation. It's been very informative to me. So Abdul Muiz here, and I'm a computer science major. So you talked about something I have very much interested in, which is the smart irrigation. I'm researching in using IoT systems to monitor water management on farms. So the use of the LoRaWAN, the ESP32, and some other IoT components with the soil moisture sensor and other sensors. All right. The idea is to use these sensors to record field data, and with the use of machine learning, we learn from the data to make predictions of irrigation times and all of that on specific fields. Right. I'm looking at how effective is that compared to the use of satellite data with your experience?
Sounds like a very interesting research you're doing.
Yeah, it is.
Would be nice to get some more information about it. Like when you have some results or something, it would be nice to go through them.
Yeah, I'd love to share that.
Yeah, I'm trying to think of your formulate an answer for your question. What I hear from you is you are measuring like quite some parameters in the field with sensors, and
Yeah,
then
exactly.
with machine learning. So that's basically AI, right? Like a little bit at least. You want to create like irrigation advice from it. Yeah, for me, it sounds like a very interesting approach. There's always a debate between what is better, a sensor or satellite information. And like a sensor measures, for example, soil moisture more accurately, but then only on one location in your field. And then satellite information, let's say, is a bit less accurate, but it represents a bigger area, maybe a whole field. It gets more values from the whole field. So then one value might be less accurate than your sensor, but because there are much more in that same field, it also has an advantage. So there has been some research whereby information from satellites gave a better advice than soil moisture sensor because of this. So then the localized area you use on a sensor. So you need quite some sensors to get a good representation of the whole field. So yeah, all have their pros and cons. It would be, yeah, it could be nice to compare what you're doing with, for example, that crop them all tool. Like you could maybe contact one of my colleagues like Elvis and give him the coordinates of the field where you do your research and fill in the data, and then see like, okay, what is the irrigation advice that comes from CropThermal that uses satellite, and you could compare it with advice that you get from your own research.
Sure. Thank you so much.
Good luck with the research. Okay, then I want to thank you again for your very active participation as well. I think I hope that I could help with a few things here and there at the end on for your own farms. And yeah, don't hesitate to reach out to me or to the team for more information about irrigation or any other vegetable growing business related topics. We are here to help you, like when your businesses flourish, then we can grow together. So it's always our goal to make sure that that you use your money, your water, your resources as good as possible, so we create a nice, sustainable, and profitable vegetable producing sector. So with that comes an end to my presentation. Thanks a lot, and please stay engaged with Holland Greentech. Thank you very much.
Thank you very much, Bram. Thank you very much, Bram. Thank you. Bye.